So let's begin our discussion of kinetics uh, by going into our temperature conversions, understanding the two temperature scales, and absolute zero. First off, recall that we said temperature is a measure of kinetic energy, and I'm going to expand on this. The absolute temperature is a measure of kinetic energy. Okay. Every scale is, but to be the most accurate, you want to have a scale where zero temperature means zero kinetic energy, and we're going to talk about that in a sec. So the two common scales that we use in science are degrees Celsius and kelvins. So degrees Celsius, this is a very common scale, and there are two very important points on the Celsius scale. Celsius is based upon behaviors of water. So at 0 degrees Celsius, this is the standard freezing point of water. Okay, so this is where ice melts and where liquid water freezes, the freezing point, 0 Celsius. Another very, very important point is 100 Celsius. 100 Celsius is the boiling point of water. So specifically, these are for water at 1 atmosphere of pressure. Okay, so standard pressure conditions, 0 freezing point, 100 boiling point. Now, the other scale that we talked about, we have kelvins here. And before I mentioned that absolute temperature is a measure of kinetic energy, kelvins are an absolute scale, meaning that you can't have negative kelvins. 0 kelvins means a complete lack of kinetic energy. The way that we can relate these two things is if I have some temperature in degrees Celsius, all I have to do is add 273, and that will give me the temperature in kelvins. If I've been given kelvins, you take the opposite, go ahead and subtract away your 273, and that'll give you your degrees Celsius. The way that you can mentally check this is that the Kelvin temperature should always be a higher value. Now, the reasoning for this is that a change in 1 degree Celsius is equal to a change of 1 Kelvin. So we're saying that if I had a sample of water boiling at 100 degrees Celsius, and we heated that up to 120 Celsius, the change that we see here is it went up by 20 degrees. Well, we take the same thing if we do our conversions and adding 273, that's going to be 100 plus 273 gives us 373 kelvins, and then 120 plus 273 is going to give us 393 kelvins. And if you check the difference here, 393 minus 373, we still gained 20, but this time the unit is kelvins. So changes to temperature are going to be the same regardless of using the Celsius or Kelvin scale. Now, last idea is that the lowest possible temperature where matter stops moving, meaning there is no kinetic energy, we call this absolute zero. So absolute zero is at 0 Kelvin, and on the Celsius scale, if we take 0 kelvins minus 273, we get negative 273 Celsius. I will assume that you have paused the video now, and I'm going to walk through our solutions. So first off, kinetic energy is equal to absolute temperature. Okay, the absolute temperature. What are the two defining points on the Celsius temperature scale? The two defining points are 0 degrees C, which is the freezing point of water, and 100 degrees C, our boiling point of water. Now convert the following temperatures. 150 Celsius are how many kelvins? So recall, degrees C plus 273 equals Kelvin. So 150 plus 273 is going to give us 423 kelvins. Now 573 kelvins are what Celsius temperature, so we're going the opposite. This is Kelvin minus 273 equals degrees Celsius. 573 minus 273 is equal to 300 Celsius. Negative 200 degrees Celsius are how many kelvins? So now I'm going negative 200 Celsius. Since it's Celsius, we're adding 273. So we will go ahead and say plus 273. That is going to be negative plus 200, so that's going to cancel to be 0, and we'll be left with positive 73 kelvins. Express the number of degrees Celsius in 173 Kelvin. Now again, going kelvins, it's going to be 173 minus 273 should give us negative 100 degrees Celsius. Lastly, if a gas is cooled by 75.5 degrees Celsius, so it loses 75.5 degrees Celsius, how many kelvins have been lost? Since the Celsius and Kelvin scale are pegged 1 to 1, for every degree Celsius that is gained or lost, 1 Kelvin is gained or lost. So a change of negative 75 degrees C, so this is a change in temperature, would be equivalent to 75.5 kelvins being lost.